Hello friends, today we will talk about operating system. So we will start with the chapter 1 of the book by Silver Church and Galvin. So basic introduction. We will learn about what operating systems do. We will learn about computer system organization. We will learn about computer system architecture, operating system structure, operating system operation, process management, memory management, storage management, protection and security, kernel data structure, and computing environments. These are what an operating system do, right? So, what is our objective? Our objective is to describe the basic organization of a computer system, to provide the major components, the understanding of major components of an operating system, to give an overview of the many types of computing environments, to learn about different type of open source operating systems like Linux, right? So what is an operating system? Operating system is a program that acts as an interface between the user and computer, or the interface between user and the computer hardware, right? The main goal of operating system is it executes user programs and solves the problems of the user. It makes the computer system easy to use, and it will make the computer hardware and the software and different computer resources like storage and CPU to use in efficiently. Okay. So what is the computer system architecture? The computer system structure. There are mainly four components of a computer system. One is hardware. Hardware gives the basic computing resources. The hardware means CPU of the computer, memory, hard disk, input output devices. These are the example of hardware. And there is operating system. Operating system is a system software which basically used as the interface between user and the computer hardware. Another is application program. Application program means uh, there are several type of software we use, like word processor, we use Microsoft Word. These softwares are called application program. These are different from system software. Application program or application softwares are different from system software. Operating system is a system software, but application program are not system software. And the fourth part is users. Users means the human who is controlling the computer, right? Okay. So these are the four components. Here we can see a computing system. There may be different type of user. Here is user 1, user 2, user 3, user 4, user n. And there will be different type of system software, not application software. Compiler, assembler, text editor. These are the application and system software. And operating system, this is another type of system software and computer hardware. These are the basic components of the computer system. So what does operating system do? It is used to make the computer more convenient and easy to use, and it is used for resource utilization, right? Next. So resource allocator and control program. So operating system can be defined in two ways. One is resource allocator, another is control program. Resource allocator means it manages all resources so that we can use the resources efficiently. Okay. And control program means it controls how a program or process will be used efficiently, right? So, as we know, there is no universally accepted definition. There are many different definitions of operating system. Uh, a good approximation is everything a vendor ships when you order an operating system. The one program which runs all the time in the computer is called the kernel. So everything other is either system program or application program. So one program that always runs into the in the computer, which we call kernel. Another program runs, which is system program or system software. It is the part of operating system. Another is application program like Microsoft Word, Microsoft Excel. These are application program. When you power up or when we switch on the computer and then power up or reboot the computer, first program which is loaded in the computer is called Bootstrap program. It is typically stored in EPROM and generally known as firmware. So Bootstrap program is generally known as the EPROM is generally known as firmware, where the Bootstrap program resides. Okay. Then the Bootstrap program loads the operating system kernel and starts computing. So, how many computer system operation there are? Okay. There are CPUs, there are device controllers, I mean USB controller, graphics adapter, disk controller. These are the device controllers. These are used for input-output operation, and CPU is used for mainly computing. CPU is the brain of the computer. So, why we need operating system? So that input-output device and CPU can execute concurrently. Okay. When its application program is finished, right? We want to run an application program for a certain amount of time. Then we need to finish the program. We finish the program by causing an interrupt. This is an important question. We finish the program by causing an interrupt. How interrupt works? There is an interrupt vector which contains the address of all the service routines. A trap or exception. Exception is a software generated interrupt. If there is an error in the software or error in the process, or if we want to end the software, or if we want to interrupt the software or finish the work of software, then a trap or exception interrupt is caused. So we can say that an operating system is interrupt driven. Means if we want to close, if we want to control a process, or if we want to finish a process, we need interrupt. Okay. There are two types of interrupt. One is polling, one is vector interrupt. We will learn about this later, right? Okay. We learn about input-output structure. So there are two type of options operating system has. One is a process or program either utilize CPU or either utilize input-output device. Input-output device means the monitor showing result in the monitor or showing data in a monitor. This is input-output operation. Or taking input from keyboard or taking input from another such USB or another device. These are the input output operations, right? So first, if any program is using input output devices, then what happens? First, this system calls. System calls means uh, the user program can be controlled. How? System calls means it requires the OS operating system to allow the user to wait an input output completion. Okay, this we will learn this later. Okay. So another work of operating system is allocating storage resource. So allocating resource is the work of operating system. And one type of resource is CPU. Another type of resource is storage. So how much storage? Storage, the amount of storage is measured by kilobyte, megabyte, gigabyte, terabyte. 1 kilobyte means 1024 bytes. 1 megabyte means 1024 square bytes. 1 gigabyte means 1024 cube bytes. 1 terabyte means 1024 to the power 4 bytes. 1 petabyte means 1024 to the power 5 bytes. Are the this is how we measure the storage, right? Storage structure. There are many types of storage. We mainly change it. We mainly classify it in two ways. One is main memory, another is secondary memory. Main memory means RAM. RAM is, you can say RAM is main memory, right? It is too much nearer than CPU, too much nearer to CPU than secondary storage. Secondary storage means hard disk or HDD, SSD, solid state disk or hard disk. These are secondary storage, right? Whenever we want to uh, execute a process, we will load it into main memory. To execute a process, the process should be loaded into the main memory, right? So speed, cost, and volatility, these are the main component of the main properties of the storage. So speed of the main memory is much more higher than the speed of the secondary memory. Cost also is for main memory is higher. For main memory, cost is also higher. Volatility. Volatility means we can change, right? Volatility means volatility means volatility means when what we can change this volatility. Caching. What do we mean by caching? Caching means copying an information from lower storage system to from slower storage system to faster storage system. So if we try to load a process from uh, secondary storage to main memory, it is called caching. Okay, this is the memory hierarchy. The top of this is the memory pyramid. We can say it memory pyramid. The topmost memory, which is registers, this is the highest. This has the highest speed, and this is the nearer to the CPU. Then cache memory. This is lower than the speed of cache is lower than the register but higher than the main memory. So if we try to go down, the speed becomes lower and lower for this memory. This is called memory hierarchy or memory pyramid. Caching. We know about caching. Okay. Yeah. Multiprocessor system. There are many type of computer system architecture. What is multiprocessor? It is also named as parallel system or tightly coupled system. It increases throughput, it increases economy of scale, it increases reliability. Reliability means uh, 1 minus probability of failure, right? This is the basic multi-processing architecture. Multi-processing means there are more than one CPU. We can see that there are three CPU, CPU 0, CPU 1, CPU 2. There are three processing units, so it is called multi-processing. Multi means multiple processing unit. Dual core. Dual core is a multi-processing unit. Dual core means there are two CPU or two processing units, right? Clustered system. If multiple systems work together, then we call it clustered system. There can be two type of cluster system. One is asymmetric cluster system, and another is system symmetric cluster system. Okay, this is cluster system. There is one cluster. This is computer one. This is computer two. There is another cluster. This is called cluster system. There are three systems: one computer, two computer, three computer. Right? These three computers are interconnected with each other. Then we can call it the clustered system. Another is multi-programming. Multi-programming means there can be one or many CPU, but one or two jobs or more jobs, multiple programs runs simultaneously, right? This is called multi-programming. Multiple program run in a single CPU. This is called multi-programming. They switch the jobs in a speedy manner that we cannot. We seem that the programs are working simultaneously. And there is time sharing or multitasking. Here, the CPU switches jobs so frequently that we see that the every programs are running simultaneously. This is called time sharing or multitasking. So this is the memory layout of multi-programming system. This is one process, two process, three process, four process. Four processes are happening in the operating system. So there are multiple programs, so we call it multiple programming system. So operating system is interrupt driven. We already told that operating system is interrupt driven. So what is interrupt? Interrupt is basically we say the operating system is to stop a program. This is called interrupt. So there are two types of interrupt. One is hardware interrupt. It is caused by hardware, and this software interrupt. Software interrupt means if any there is software error like division by zero, then the program will be stopped. Uh, if operating system requests for a software or a program to stop, then that is a system interrupt. If there is an infinite loop, there is a certain condition that the software is run. If we do not trap or do not finish the software, then or do not finish the work of the software, then the software will run infinitely. So there is an interrupt we will use, which are software interrupt. These are the example of software interrupt. So another type of work of operating system is to protect itself in other system components. Okay, there are two privilege for any resource allocation. There are two privilege. One is user mode, which is less privileged mode. Another is kernel mode, which is more privileged mode. Right? This is the structure of user mode and kernel mode. Right? So one work of computer system is process management. So if we write a program, it may be C, C++, or Java, and we store it basically in the secondary memory, then it becomes a program. The written code or some software or something which are in secondary memory, it is called program. But when a program is loaded to primary memory, it becomes active. It starts to utilize CPU, right? it becomes active. So it is an active entity. When a program is loaded into the main memory, it is called process. So process is an active entity. Okay. So program every process, the data for the every process, the state of the every process is used by is denoted by process control block, which we will learn later. There, a variable is program counter. Program counter we use to know if a process is interrupted, then next which process starts to execute, right? Okay. So what is the work of operating system? One is process management, another is memory management. Memory management, we know that we have a limited memory, right? Memory means the main memory. We have a limited main memory, typically 4 GB RAM or 8 GB RAM or 16 GB RAM. So we need to utilize that memory efficiently, right? If a program is 4 GB, in a 4 GB RAM, only one program should be executed or only one program should be run. But operating system will try to use that memory to maximum CPU utilization occurs. So that maximum CPU utilization occurs. So that maximum process can take part or maximum process can work, can be worked, right? This is called memory management. Another is storage management. Storage means every program is written as a file, right? So we try to optimize the storage required for a file, right? This is called storage management. So this is the hierarchy of the storage. We will learn later how a operating system do storage management. Another is controlling input output. Another work is operating system is controlling input output, managing input output device, right? Another work is protection and security. Another work is computer security, right? It it provides a computer. It makes the computer safe from viruses, right, or theft. These are the work of operating system. Kernel data structure, we know about single linked list, double linked list, circular linked list, or binary search tree, we know. BST, we know in data structure algorithm. Hash function, we know. Mm. Traditional computer computing environments like Windows, there is mobile or Android or Apple iOS computing environments. These are example of operating system. Um, these are okay. So this is all about the introduction of the computer system. Thank you for watching this video.